Okay, good morning. Afternoon. No, we are in Spain this morning. Sundays we even don't have a breakfast till now. Okay, so thank you for coming. And today we have a keynote from Professor Pedro Larrañaga. It's my very pleasure to introduce today to him. I know probably that all of you know the works of his groups and his works in estimation and distribution algorithms and other topics. Pedro is full professor from the Polytechnic University of Madrid, Polytechnical University of Madrid, in computer science and artificial intelligence. He co-leads the computational intelligence group in the university, and he has published more than 150 papers in journals of impact factor and has supervised more than 20 PhD theses. He is fellow also of the European Coordination Committee for Artificial Intelligence in 2012, and he was awarded also with the Spanish Computer Science Prize Award in 2013. And he has published several books, and for example, recently, Industrial Applications for Machine Learning and Data-Driven Computational Neuroscience. And his research interests are in several areas, but mainly in probabilistic graphical models, media-heuristic optimization, and with real-world applications, where he leads several important projects, European projects and Spanish projects. And of course, in the area of estimation of distribution algorithms, he is one of the pioneers in this area. So today we are going to have a talk titled "Estimation of Distribution Algorithms in Machine Learning." I'm sure that you are going to enjoy and to learn a lot of this. Thank you, Pedro.
Thank you, Iñaki, for this kind presentation, and also thank you to the organizer for giving me the opportunity to share these ideas about EDAs in machine learning. So this is the outline of the talk. So I will introduce EDAs with a toy example, and then some concept on Bayesian networks. That is the base for these EDAs. And then we will see some applications of EDAs in different machine learning topics, from preprocessing to supervised classification, clustering, reinforcement learning, or Bayesian networks. So, my opinion, machine learning today nowadays is one of the main branches in artificial intelligence. And in machine learning, what people try to do is to transform some one data set into a computational statistical model. And with this model, you try to take some rational decisions about the world. But in this process, you need to solve two different types of optimizations. On one hand, you need to specify the structure of the model, for example, the topology of an artificial neural network. And in a second step, you need to specify some parameters. The first tag can be seen as a combinatorial optimization problem. The second one is a continuous optimization problem. And only for having one idea of the cardinality space of some of these problems, Here we have the cardinality space of the feature subset selection problem when we have n predictor variable. This cardinality is exponential on the number of variables, as we can see here. But we have other examples. For example, this Stirling number that refers to the possible partitional clustering assignment, or this super exponential number corresponding to the possible directed acyclic graph for Bayesian methods. So this is a recursive formula that finally is super exponential. In addition to this, sometimes we need to specify or optimize the parameters. Sometimes we have some closed formula and we obtain this by maximum likelihood estimation. But in other circumstances, in other scenarios, we need to use heuristics. I will follow my presentation. In my presentation, I will follow this organization of machine learning methods. I would like to clarify that these are standard machine learning methods. I don't include transfer learning, active learning, other kind federated learning, other kind of more sophisticated machine learning methods. I am following the ideas in this book that we recently published in Cambridge University Press, and it's about the use of this method in computational neuroscience. So the idea is to organize the machine learning methods in preprocessing, supervised classification, and in this case, I will distinguish between non-probabilistic classifier, probabilistic classifier, ensembles or meta-classifiers, and multidimensional or multi-label classifiers. Then 3 types of clustering: hierarchical, partitional, and probabilistic, reinforcement learning, and 2 types of probabilistic graphical models, Bayesian network and Markov network. Okay, let's start with EDAs. I will try to introduce the general ideas with this toy example that is correspond to the 1 max function defined in a 6 binary dimensional space, where of course we know what is the maximum of this function is at the point 1, 1, 1, 1, 1, 1. But we will start as in a standard way for any evolutionary computation method. So it means that we will start with proposing one random population, and let's assume that this is our random population. Each number, each gene, each value of these variables, 1 or 0, has been sampled from a Bernoulli distribution with parameter p equal to 0.5. So we have the same probability of 0 or 1. And as a result of this, the average value of the fitness function here in the last column should be close to 3. In the next step, let's say that we select individuals by truncation, and we select these 10 individuals. And now I don't consider anymore the value of the fitness function. I only consider the characteristic of the individuals, and I try to learn the joint probability distribution of these individuals, of these best individuals. But as you can imagine, we have here 64 parameters to be estimated, and only with 10 points is a very difficult task. So we decide to approximate the joint probability distribution over these 6 variables as a product of univariate marginal distributions. So in this way, we only need to specify or to estimate 6 parameters one parameter per variable, and the estimation here, for example, can be done with maximum likelihood estimation with the relative frequency, the frequency of ones, and we do this for the 6th variable, obtaining something like this. At this point, we discard the population, and we only work with the joint probability distribution, in this case, factorized as a product of univariate variables. So from this distribution, we will sample a new population of individuals. And here we have the first individual as a result of 6 values from sampled from a uniform 0-1 distribution, and comparing the value with the probability, we decide 1 or 0, 1 or 0. And this is our first individual, 110, 111. So this is the first individual, evaluation function 5. And in this way, we can obtain the rest of individual. We can see two important things. The first one is that now the expected value of the average of this fitness function is bigger than 3. And on the other hand, we have one individual who is now the optimum. In any case, what we do is we will repeat this process until a given previously established condition is met, stopping condition is met. So this is exactly, or more or less, the ideas in the univariate EDAs. This is one example of univariate EDAs called univariate marginal distribution algorithm. But we can do something better if we consider some relationship among the variables, as for example here in this chain. This is called mimic. And we can consider any kind of relationship among the variables, as in this case, organizing this relationship as a directed acyclic graph, and speaking of multivariate EDAs. Notice that this year, people working in different countries, especially in the United States, Germany, or Spain, we propose different algorithms, more or less similar variants of the same approach. Of course, this idea can be extended to a continuous domain, but in this case, what people do is to assume Gaussianity. We assume Gaussianity in each of the variables, and we assume Gaussianity in the joint density. This is one big restriction. So here we have more or less the graphical representation of the graphical scheme of an EDA. We start with a population of candidate solution, capital M, 20 in our case. We select some of them, 10 in our case. We learn a probabilistic graphical model, let's say Bayesian network, Gaussian network. We sample from this model to obtain a new population, and we repeat these 3 steps: selection, learning, sampling, until the meeting condition stopping condition is. This is a typical evolution of the different structure of Bayesian networks in discrete problems. So here we have at the beginning, in the first generation, or generation number 0, we have a very dense graph, and at the end, when we are very close to the convergence of the population, and convergence of the population means that almost all the individuals are equal or very similar. And in this case, the arc disappears because each variable works independently on the rest. We can introduce some variants to this. Of course, we can consider the fitness function, something that I said before that is not necessary in our first version. We didn't consider, but we can consider the fitness function of the best individual, of the selected individual, and label this individual in two types: the very, very good individuals and these individuals that are selected, but they are not so good, and transforming now the problem into a supervised classification problem. This can be done. We are incorporating this information, and of course, we can also work in many objective, multi-objective optimization problem by using these variables in red, or the variables representing the objectives, and the variable representing the variables of the domain in the same graph. Okay, here we have some books, some special issues, and a lot of papers. I have selected some of them, and I will comment only one sentence or something like this for the references in blue. Okay, so this reference use a restrictive Bowman machine instead of a Bayesian level. In the second one, variational autoencoder based EDAs are proposed. Here we have one interesting paper using a more sophisticated way to selecting the best individual. And in this case, improving Gaussianity EDAs, Gaussian EDAs, something similar in this case. Here, the hybridization of EDAs. And in these two labs, using regularization in order to obtain a sparse structure in the Bayesian levels. Of course, there is a lot of work in theoretical papers, mainly trying to prove under which condition we can guarantee the convergence of the algorithm. Almost all the papers are related with univariate EDAs, and I would like to remark these two recent papers on the topic. Okay, I changed to Bayesian levels, and I would like to give some ideas about the Bayesian levels. I would like to introduce mainly one concept, that is the concept of conditional independency between triplets of variables. A Bayesian level is a graphical representation of a joint probability distribution, no more than this. And in a Bayesian level, we have two things. We have a qualitative part, that is the DAG, the direct data feed graph. And we have a quantitative part that are the conditional probability tables. So the direct data feed graph represents the relationship among these variables. Let's take this toy example in neuroscience. H is the parent in the DAG sense of neural atrophy and stroke. These two are the parents of dementia, and stroke can be considered as the parent of paralysis. Okay, so this structure are representing some conditional independency between triplets of variables. This concept is more general than the standard independency between pairs of variables and refers to three variables. Let's say W, T, and Z. And we said that W and T are conditionally independent given Z if and only if this is true for all possible values of the three variables. What is the meaning of this is quite clear. If you know the value of Z, to know the value of T is irrelevant for the probability distribution of double B. I will illustrate this concept in the next slide with one example. But let me say that when you have this kind of model, you can do any kind of reasoning with the model. You can do diagnosis, you can do adaptive inference, you can do counterfactual reasoning, you can do any kind of reasoning. And the meaning of reasoning is to introduce some evidence, as for example, here the patient has a stroke, and then to propagate this evidence through the network, changing the probability distribution of the rest of the variables. I will see this with this example where I try to give or to illustrate the idea of conditional independence. Here we have the marginal distribution of each of the variables in the system. In this graph, we introduce only one evidence, and we can see that the probability of dementia increased dramatically from 17 to 52. And now we introduce another evidence here, neural atrophy, yes, increasing again the probability of dementia. But what is interesting is to notice that now when we introduce the third evidence about age, it is a young patient, the probability of dementia and the probability of paralysis remain the same as in the previous figure. So with this, I will try to show you the concept of conditional independency. The idea is more or less that when you know the value of neural atrophy and the value of a stroke, this knowledge is blocking all the information from age to the other two variables. Is blocking, and technically we said that age and dementia and age and paralysis are conditionally independent given neural atrophy and stroke. Of course, we need to prove this for all possible values of the variables, but it's no more than one illustration. What is also important is to see that, or to notice that we can learn Bayesian networks from data, and this means to learn parameters and to learn the structure. Parameters by maximum likelihood estimation or by Bayesian approaches, assuming some prior distribution. Here people use the Dirichlet distribution for categorical variables or the Wizard distribution for normal variables or for Gaussian. And to learn the structure can be done in two different ways. In the evolutionary computation application, this is the standard way, optimizing a score, of course. And here we have two families of scores, penalized likelihood and Bayesian scores, as for example, the marginal likelihood. And we can say something about the search engines. And here when we have more than, let's say, 30 nodes in 30 variables in our system, we need to use approximate search, or we need to use heuristic. And in this case, almost all kinds of heuristic have been used, including EDAs. Okay, here we have some books on the topic. I would remark this seminar book by Per, this very complete book by Kohler and Feldman, and this recent one. Okay. Sorry. Let's start with the application of EDAs. In this case, in pre-processing. I found only two applications in this topic. One is about the improvement of, is about the visualization. Is how to improve the table interpretation using EDAs, or can be used any evolutionary computation approach for this problem. So the idea is that the way rows and columns are ordered in a table is affect his reliability, as we can see in these three figures. So trying to obtain the optimal ordering of this table is equivalent to solve two concatenate traveling salesman problems, one referring to the rows and the other referring to the columns. And here the author proposed the use of discrete and the use of continuous representation of the individuals. In discrete, for example, we split the representation into parts. The first one for the rows, and we need to have one permutation, and the second one for the columns. Okay. In continuous is easier in the sense that we can transform any vector of real values into a permutation. So this is the paper, and the second application of EDAs in preprocessing is in one very transversal work in machine learning that correspond to the discretization of continuous variables. We can discretize a continuous variable in different ways. Here we are considering a supervised classification problem. So the discretization is supervised by the label, by the C class. And the interesting thing in this application is that the discretization is done in a multidimensional way. It means that all continuous variables are discretized at the same time. So we can do this if this is our original data set. We can do this by considering individuals in EDA or in any other evolutionary computation approach, by considering individuals in the EDA as real vectors, where each point represents the good point for the different bins. It means that we need to establish the number of bins in advance. For example, for the first variable, let's assume that we want only two intervals. So we need to define one good point. If this number 0 is smaller than 5, it will be represented as 1. If 17 is bigger than 5, it will be represented as 2. This is more or less the idea. The approach is wrapper in the sense that it will be evaluated. The fitness function is the performance of the classifier. So here the approach was developed in combination with naive Bayes, that is the classifier method. Okay, I move to EDAs in supervised classification. And in this case, a very transversal problem is feature subset selection. Of course, we nowadays, when we have a patient, the monitorization of a patient, or when we have a lot of sensor, or in bioinformatics, computational biology, we can obtain thousands of variables at the same time. But a lot of them are irrelevant for the class variable. A lot of them are redundant. And the idea for feature subset selection is to build a parsimonious classifier, a very sparse classifier with very few predictor variables, and only selecting those variables that are relevant and non-redundant for the classifier. So this can be done in two different ways, filter and wrapper. In the filter approach, we only consider intrinsic properties of the data, for example, measures from information theory, mutual information or something like this, or for example, the likelihood of the data. And in a wrapper approach, we need to evaluate the subset with a given classifier. with a classifier that we built with this specific subset. This is the approach proposed in this paper, and the representation of individual is very simple and very clear, because one individual in any this problem has been approached many times with genetic algorithms, and the representation is the same. So we represent each individual with a binary string with a length equal to the number of predictor variables, and 1 represents that the variable is selected, 0 represents that is not selected. So apart from this, I didn't mention, but when we have several references, I will try to present the seminal paper, okay? The original paper, the first paper from the best of my knowledge. But here we have, and in blue, I have something that for me is remarkable. For example, this work on using a B-objective EDA, trying to maximize the performance of the classifier in terms of the recall or accuracy or the area that the ROC could maximize, and at the same time to minimize the number of predictor variables. So this is a B-objective approach. Starting with non-probabilistic classifier, the most simple is this one, the k-nearest neighbor, that you probably know. And in this classifier, we try to label, let's say, this green point. We need to see to compute the neighbors of the point that we try to classify, and then to see what is the label with the most frequent label in the neighborhood. In this case, is red. So according to the standard version of the k-nearest neighbor, we will classify this green point as red. Okay, but this paradigm depends a lot on the definition of the distance. So here we have a new point that we try to maximize, x in bold, and this is a point with a label in our data set. So we can try to optimize the weights WJ for each of the coordinates. And this is exactly what these people do with the use of EDAs in discrete and continuous domains and using multivariate EDAs. Classification trees, decision trees are, of course, one of the most interpretable and one of the most transparent supervised classification paradigms. And in this case, the way of building this classification tree is by selecting the root node and the internal nodes in a greedy way. So, for example, we define some criterion as the Gini or as the gain ratio, and at each step or in each branch, we select the variable maximizing this criteria. It's completely deterministic. So this author proposed to avoid this deterministic aspect, introducing the use of UMDA, univariate marginal distribution algorithms, was presented in the CEC Congress 5 years ago. This all work is quite simple in the sense that try to obtain a classifier system from a Pittsburgh-like approach, in the sense that the rules of this rule is the classifier system, and we allow different possibilities here in the rules that can be obtained as a disjunction of simple antecedent. Only one paper in this topic. Let's move to artificial neural network, where I've been able to find something like 10 topics or 10 papers or something like this. The original one was introduced by Baluja in 1995. And the idea is to obtain the optimal weights of the connection between two consecutive layers in a multi-layer perfectron. This is more or less the idea, and to use evolutionary computation as an alternative to the backpropagation method. In this case, Baluja used one variant of an univariate marginal distribution algorithm that is called population-based incremental learning. This is a very popular algorithm, and in this algorithm we obtain the probability distribution of the individuals in generation A+1 as a combination of the probability distribution in the previous generation and the relative frequency or the probability that you obtain for the best individuals in this given population. Of course, this is not the only problem solved using EDAs in artificial neural network. I would like to comment this paper by Tantupaf, where the objective was to optimize the architecture instead of the weights. So he was interested in an optimal pruning of the neural networks. And here we have three recent papers, one in convolutional neural networks, the other one in Hopfield neural networks, and the last one in stacked autoencoder. So let's move now to probabilistic classifiers. Between probabilistic classifier, probably this logistic regression is the most popular, mainly in medical application. And the reason is because the parameters beta are interpretable from the point of view of odds radius. But the problem in this case, here we have the model that is a sigmoid function where we try to estimate the beta parameters. And the estimation of these beta parameters used to be done trying to maximize the likelihood function. It means that we need to solve this system with n+1 equation and n+1 parameters. And the bad news in this case is that this system has not a closed formula as a solution. And what people do is use iterative algorithms, mainly this one of Newton-Raphson, in order to obtain the beta values, maximizing this likelihood function. Okay, of course, here we can use EDAs or any other evolutionary computation approach in a very simple way with representation of each individual can be represented for a vector of real numbers with cardinality n+1. And in this case, the author proposed the use of UNDA in a Gaussian version, of course. Exactly two UNDAs, one for calibration, that is the maximization of the log likelihood, and the other one for the discrimination, that is to maximize this case, the area under the drop curve. So after obtaining the solution of these two different problems, the best individual that you obtain with each of these UNDAs were evaluated with the other objective, and we represent an approximation of the Pareto front for the B-objective problem. So it's a very tricky, sometimes. Here we have 3 different references. The original one was published in this statistical journal talk. Bayesian classifiers, Bayesian classifier can be organized in 3 different types. And the organization depends on how do you factorize this joint probability distribution, probability of C and X1, Xn, according to these the different ways that you can factorize this. We have 3 different families of Bayesian classifiers. For this talk, we are interested in this family, augmented life-based models. That means that the parent, the class variable, the C, the variable that you try to predict, has no parent in the graphical representation. Examples of these is the naive Bayes, and also this semi-naive Bayes that I will try to show you how EDAs were applied in this semi-naive Bayes model. Semi-naive is can be considered as one extension of naive. The structure is the same. So here we have some nodes that are conditionally independent given C, but in semi-naive, the idea is that you can consider something that is called supernodes. For example, this is a supernode. In this supernode, we have the Cartesian product between 2 or more original predictor variables. Here we have the Cartesian product between X1 and X3. We can represent this structure in a very simple way as this array 0, 1, 1, 2, meaning that the first variable and the first are in the first node or supernode. The second variable is not in the model, and the last variable is in another node. So this is the paper. Moving now to ensembles, I only found this paper related with boosting, more specifically with AdaBoost. AdaBoost, that is or can be considered as the most popular ensemble. In this case, the authors ran AdaBoost approach to the problem. So taking a data set with bootstrap resampling and providing more weights to incorrectly classify samples and so on the standard way, they obtain, let's say, capital L classifiers, and then by using weighted majority vote, they decide the class. And this decision, these weighted values for each of the classifier will be the starting point for an UNDA. These are the starting point for an UNDA. So this number, this weight of this classifier is the expectation of the first Gaussian variable, and so on. So it was also introduced in CEC 4 years ago. And I moved to clustering. In clustering, we have 3 different types of clustering. Perhaps the oldest one is this hierarchical clustering. And more specifically, agglomerative hierarchical clustering. In this type of clustering, at the beginning, you have as many clusters as objects you try to group. And then in one iterative and greedy process, at each step, you merge the closest object or the closest subset of object in such a way that finally we will have all the objects in only one group. By splitting this at any point, you can obtain the different groups, as in this example, we obtained 4 different groups. So in this present paper, the author introduced on stochasticity in the merging process, trying to avoid this deterministic aspect of the agglomerative hierarchical clustering. Okay, I have found several papers on partitional clustering. Perhaps it's the most popular type of clustering, and especially in K-means. Here I represent the original Forgy paper, where the computation of the new centroids is done when all the object has been assigned to the closest centroid. And in this case, by using an object membership representation, that is a very simple representation with an individual of string, is a string of length capital N. N is the number of objects, and the value is exactly the cluster to this object. And in this case, a bivariate and a multivariate EDA were applied. But I would like to remark other words. For example, here in the medoid approach, that is very close to K-means. In K-means, in K-medoid, the centroid should be original points in the data set. In K-means, this is not mandatory. And here we have also one paper in affinity propagation clustering, that is a kind of clustering quite interesting, published in Science several years ago. And I would like to remark also this paper where EDAs have been used for the automatic generation of clustering method, a kind of clustering method in the family of the density-based DB-scan methods. Okay, to finish with clustering, here we have probabilistic clustering, and in this case we are more flexible. It's a kind of fuzzy clustering in one sense. Each object belongs to all the cluster with a given probability. And the idea is that you need to use in one intensive way the expectation maximization algorithm in order to obtain the assignment of this hidden variable. In this application, UNDA were used to obtain the structure of these variables. But here we have 2 interesting works apart from this one. This very old paper using PEBIL, again, population-based incremental learning, was developed for hidden Markov model. That in one sense is very similar. It's a kind of a probabilistic graphical model, but for continuous or for dynamic scenarios. And I would like to remark also this paper where some people from Berkeley University connect the expectation of distribution algorithm with the estimation of distribution algorithm, with the expectation maximization algorithm. Okay, only one paper in this reinforcement learning, and in this case, the paper tried to obtain the optimal policy for this agent. Try to, in one sense, to define the appropriate action for a given state, in the sense that maximize the expected reward. To do this, conditional Markov fields were proposed by this author. EDAs have been applied also in optimization in Bayesian network, and I only introduced this work for learning from data Bayesian network. This is the original or the seminal paper, and here, as before, the representation of the individual represent connectivity matrix. Other different works in this topic speak about partial abductive problem, or about this very technical paper on triangulation of the moral graph. So, okay. To finish, to conclude, I would like to see again this slide. And this is one of the slides that we see at the beginning of the talk. And here we have in red the topics where EDAs, or I've not been able to find any paper on application of EDAs. Remarkable here in meta classifiers, only in boosting. But as conclusion, for me, EDAs are competitive with the state-of-the-art heuristic in machine learning. I haven't presented any experimental result, but we can find this in the papers, in the different papers. In addition to this, Bayesian network is a framework that is interpretable. Not only we don't speak only about the explainability of machine learning. We speak about something that is stronger, that is interpretable for machine learning and for optimization tasks. And here we list some possible topics on EDAs. We can incorporate some advance in the methodology for learning Bayesian network. We can incorporate this kind of semi-parametric Bayesian network in order to avoid the Gaussian assumption that is very strong in some cases. Or we can, for example, in different topics here, we can use EDAs for visualization of parallel coordinates, or for multivariate filtering in feature subset selection, prototype selection, the election of the distance in nearest neighbor, a lot of different topics that where you can use EDAs, or you can use any other evolutionary computation approach. So thank you very much for your attention.
Okay. Thank you, Pedro. Any questions?
I was wondering, you're talking about EDAs in feature selection. Would you be able to say about that in comparison to other algorithms?
Okay. So this is in the paper that I presented before. In this paper, we compare EDAs. In this case, it's an old paper that was published in Artificial Intelligence Journal, and we compare EDAs, in this case, multivariate EDAs, as I said before, in a rapid way, using a decision tree and a naive Bayes classifier. And we compare with genetic algorithms, and we compare also with other iterative search algorithms for feature subset selection. So the comparisons were quite well for ETNA. Yeah. I would like to say something that I didn't mention during the talk, that we also did this for almost in all papers, and the idea is that when you apply any kind of evolutionary computation to a machine learning method, especially in classification problems, as in this case, what all people do is to assign the fitness function as a point estimation, as a 1 point. However, what you need to do is to use honest estimation method in order to estimate the performance of the classifier. An honest estimation method means K4 cross-validation, means bootstrap, means repeated holdout. And in this case, you don't obtain a point estimation. What you obtain is an interval estimation. So the way you compare individuals, in my opinion, technically is not is something to discuss. It's not very clear if this is the proper way, or you need to do an hypothesis test or something like this.
Yes, so thank you for presenting through the applications. I have a comment and a question. My comment is, in the conclusion, you say you didn't need an experimental results because the papers. So they come to state of the art, sending the papers. The state of the art in machine learning is very fast, especially so I think maybe some results.
Yeah, of course.
My question is maybe what is interesting. Again, you said several times in your talk that EDAs are in your spectrum. But what is interesting is when are EDAs beneficial compared to conventional process computation. That's probably practitioners, students, and on fields and so.
Yeah. Okay. So thank you for your question. It's interesting question, but my answer is that I don't have any answer. It's difficult to. I think that any you can set something general. I understand that you need to prove with one algorithm. You need to experiment with different algorithms. For me, the attractive of EDAs is because of his. They are very sound mathematically or probabilistically. They are sound, and this is the main attraction for me. And also, you can. They are not black boxes as other evolutionary computation, in my opinion. They are more interpretable because you visualize, in one sense, the landscape. In one sense, you can visualize the landscape, and you can obtain more information about the landscape. In addition to this, you can incorporate some characteristic of the problem. I didn't mention, but for example, in the SAT problem, you can incorporate the problem itself in the Markov network model. So I don't have answer for your question.
My first question would be what do you think about combining a crossover of mutation operators and EDAs? There are, I suppose, some tentatives, and it's a way for managing exploration given by standard operators and mediate more excess exploitation.
I think that it depends on the problem. It depends on the problem. I started working on genetic algorithms. And for example, my PhD was about the use of genetic algorithms in some problems in Bayesian networks. But my main problem in this case was that I was interested in solving permutational to find the best ordering. And in this case, crossover mutation operator, you need to specify or you need to define ad hoc crossover or mutation operator. And for me, this was something disappointed. I didn't like to work in this way. So with EDAs, you have a more general framework to work. And of course, you can hybridize EDAs with GAs, as a lot of work has done. And in this way, you can perhaps improve your exploitation. Okay.
So we all learned about trying to deduce causality through correlation. And yet Judea Pearls had some interesting work lately. It was taking something like Bayesian networks and created causal networks and been able to quantify from causal networks what sort of causal relationships there might be, what sort of interventions might be, are very useful. So what you would say about that whole causal inferencing stuff that he's talking about?
Yeah, it's an interesting question. I'm not an expert on causality, but what is true is that Judea Pearl has introduced a new way for thinking on causality. But this way is different from the standard statistical approach to causality. In any case, there are some algorithms for learning causal Bayesian networks. For example, the work by Glimmer, people from Pittsburgh University, when they learned the Bayesian network by conditional independency tests, something that I said that in this area, in ordinary computation, people don't use this approach. And in this case, you can consider, under several circumstances, you can consider that the network that you obtain are causal. I would like perhaps to add also that something that is a very hot topic nowadays, that is the counterfactual reasoning with this type of models can be done in Bayesian network in a more or less easy way. But I am not an expert in causal Bayesian network. Sorry.
Okay, so probably you don't have time for more questions. So thanks again, Pedro, for this. Sí.
Okay. So, good morning, everybody. And I'm saying good morning because this is Spain, and morning, afternoon doesn't begin until you eat. Okay, so this is morning. Okay, I hope I can see that you survived last night's dinner, so that's good. You all look quite well, at least from this distance, which is nice. If you were online, I would see your faces close, and that would be terrible. Okie doke. Okay, I can see myself. Hello also to the people who are online. Alrighty, so we have to go really fast because there's many awards to be given, and you will be wanting to have lunch as well. So, okay, so ¿qué? Para pasar, ¿qué? ¿De dónde se pasa? Aquí. Ah, vale. Hello. Espera, yo le doy aquí. Ahí.
No, esto está puesto.
Con las flechas. Vale, okay. Okay, so you need a student to tell you that. Alrighty, so this is me. Hi, I'm Anna. In case you didn't know me, I'm the one who's been pestering you all day. Right. I'm the Vice President of Species and the coordinator of EvoStar 2022. And so we have a number of awards to give for this year. Old Crocs, for those of you who are new to EvoStar, the Old Croc Award is the name that Ernesto Costa, where is he there? Ernesto got this name to design the EvoStar Award for Outstanding Contribution to Evolutionary Computation in Europe. So we just call it the Croc Award, because apparently, according to Ernesto, the people who get it are old crocodiles. Okay, then we have Best Paper Awards and other awards that you will see in a minute. Okay, so, right, in the past 2 years, the Old Croc Award was given online, so that wasn't so nice. And this year, we want to compensate the people who got it by being nice to them here. So we have Conor Ryan and Juan Romero. Conor couldn't make it. And then we have Gabriela Ochoa for 2020, but she's here. Juan and Gabriela are both here. So, right, first of all, we are going to talk about the person or persons who are getting this award this year. And I would like to, if any students that were in the reception on Tuesday, any students left? No. Okay, you're there. So maybe you remember I was telling you when I was like in the time of the dinosaurs, I went to my first EvoStar. It wasn't called EvoStar at the time, and this was in 1999. And I'm from Spain. I was doing my PhD in Scotland, and I went to Sweden. And then there was this person there that I met, and we shared a room together. And since then, that was like, what, 23 years ago. Since then, we've been collaborating. We've done many things together. We've been track chairs, we've been co-chairing things, all sorts of things. And our relationship has lasted. This is not the reason why she's getting the award. It's just because she's so good. And she's just there, and you know who you are. So can you stand up, amigo? Please give us a hand. So, that picture there? Hold on, a bit more. Oh, more. There is more.
Shall I open it? We don't have time. At lunch, I'll open.
This is.
Oh, that's a designer item.
This is the most desired thing in the conference. Everybody seems to be wanting one. So Aniko bought the special edition black, which as you know is there like the. Please, Gabriela and Juan, where are you? A big hand for them too, please. Cuidado, no te doy la otra. Okay, so, right. So this is the list of the former outcrops, now including Aniko. And then I have to call Wolfgang for this.
So I'm announcing something, I'm not getting in the hole.
Not this year.
So how do I?
Ah.
No. Yes, so one of the old crooks unfortunately has died this year, and that's Julian Miller, who got the award in 2011. And I think many of you know him as one of those deep thinkers in our field who contributed a lot over, I think, 25, 30 years, so 25 at least. And so the community, species, the society has decided that we want to do something in his name to honor him for his contributions. And that is going to be a new award that we want to establish from next year on. There was a little committee that thought about this, and the Julian Francis Miller Award will be given for important contributions to the algorithmic exploration and also embodiment of evolution, development, and or learning. And this is an award that will be given, the rules are currently set this way, and it might be adapted over time, but for now, it will be given to one or more individuals with a plaque and a prize, and delivered every year at the EvoStar conference. Any member of the scientific community may nominate a colleague. There will be a selection committee that makes a suggestion to the species board, and the board will then decide who it is that will win this award. Anyway, there are a few dates here, and we'll publish the rules on the website of species. So think about someone who could imagine having similar standing than Julian Miller and honoring his name. And that is going to start this July. So please think, and if you have, the rules are pretty easy to apply. There will be not lots of formalities, and hopefully we'll find someone well-deserving such a prize in the future. Okay, Thank you. That's it.
Thank you. Okay, so we'll move on to the best paper awards, and I'm needing Sebastian. I cannot find him. Where are all the chairs for the different Wolfgang, don't go away because you have to stay as well. And Penusal. Penusal, Sebastian. Right, okay. That's it. Right. Okay, so EuroGP nominations. We have these three papers. Nicolas and David were also outstanding students for this year. So big hand for the three nominated. And the best paper award for EuroGP is, I cannot say it, Xing Xing Huang, Fang Fang Sang, Jimei, and Meng Si Sang. Unfortunately, they cannot pick it up because they are in New Zealand. So you can show the certificate. You can make the picture with them. Yes, today. Yes, come over. Yes, there. Okay, I'm sure they'll be following from there. Okay, though. So next one, Evo Apps nominations. We have Christian, Atusa, and Yuri. The three of them were nominated outstanding students, and the winner is Christian, Sintrano, and Jamal Tutu. They're both here. Who's Jamal? ¿Dónde está Jamal?
Ahí, vete.
Your
Come on.
Okay, you want to say hello online?
Hello.
Okay, next, Evo Cup nomination, we have Marcus and Jonas, who are there somewhere. They're also outstanding students for this year. And then we have Piotr, Andrei, and three Piotr's in the same paper. That's excellent. And the winner is Marcus, Jonas, Marcus. Someone say hello to the people online. So the amazing thing about Marcus and Jonas is the first name and the surname and with the same letter. So isn't that great?
Hello.
Okay, so oops. There is also a t-shirt for you, but you didn't come to get it. So I don't know if we can just give it away or what.
I'm missing one. Yes. I didn't.
Okay, so we just sell yours.
Yeah. No, I will.
No, you will come back. Okay. All righty. Next, we have the Evo Musa nominations. We have Tassos, Oneris, and Imke, as again, they were outstanding students of this year. And the winner is Tassos.
It's not me.
Come this way, say hello first, and then you take the picture.
Hello.
Okay. Now this year we have this.
Can I have a t-shirt?
No, Thiago cannot have a t-shirt. All right. We have the evolutionary machine learning track, which is a joint track between EuroGP and Evo Apps. So we have Wolfgang and Penusal to hand over. And then the nominated are Leonardo, Rui, and Tim. And the winner is Rui, Emma, David, and Jeremy. We forgot to print your thing. We'll print it later.
We need a great performance, just so. Sorry for that.
Congratulations. Congratulations.
Sorry for that.
Congratulations.
Okay, look. Right, next. We have, this is our list of 2022 outstanding students. There are quite a few this year, and you can see that many of them got their nominated as best papers, so we are very proud of them. Some of them cannot be here, they are online. And some of them, two of them actually have been nominated 2 years in a row, like Amir Hussein and Christian, so big hand for them all. And okay, if you want to know what it takes to become an outstanding student, you can go on to the web page and you will see the requisites for being nominated. One important requisite is tick the box, right? Okay. If you don't do this, then you can complain afterwards, but I'll be mad at you, all right? Okay, so big hand for all our outstanding students. And I have a t-shirt still to give away, but you can come later and I'll give it to you. Okay, though, so what next? Okay. Those of the outstanding students who wanted to candidate for best student poster, they brought their posters. So we have a vote. As well, all those of you who were there, I was pestering you for that. So we have a winner and we have 2 runners-up. So the winner for the best student poster, not paper, because we do not judge the paper, we just judge the poster. Okay. So the winner for the best student poster is Georgia. And Yuri and Inke, are you there? Yuri and Inke? Yes, no? Yes, you get your thinking. Inke is there? Yes, she's there. Do you want to come up or where's the link? ¿Dónde está? Lo tienes. Vale.
Like take a picture of it.
Just take a picture. Alrighty. So, right, this prize it used to be called the dissemination prize, and it was given to that person or thing that contributed the most to the Wikipedia page. And that thing is the Wikipedia bot. And that, you know why that is? Because you are not contributing to the Wikipedia page. So all you go and contribute and you get a nice nomination like this. Okay, so please. Okay, look. Right, next one. Other things that have happened since last year. We have the species scholarships. I'm sorry that Christine is not here to talk about this. She couldn't make it, but she's the scholarship chair. And at this point, she's collecting all the candidacies for host candidates, basically, right? And so if you want as host to hold to be a host for a scholarship awardee, then you just send your information you'll go to the species webpage and you will find what information is required for this. And you can hold a student for 3 months, and not necessarily a student, could be a recent postgraduate, and per month the student gets, the person gets 900 euros, okay? So because of the pandemic, there's been a bit of a mess. The students couldn't start when they were required, whatever. But we have already 5 people who have finished: Adam, Najim, Bianca, and Andrea. And there are 4 people in progress: Anna, Stefano, Diderik, and Yuri, who is here. And Yuri just started recently, but because he was working ahead of the schedule, he was working remotely with his host supervisor. They already got a paper and it was nominated, and so it was fantastic, right? And then we have 4 more people. Sergio, who is here too. Sergio designed the nice t-shirts. Here it is. He's a great designer. He designed the species logo. Well, he's a great designer, Sergio. We love you. And everybody is dying to get one of your t-shirts. So that's it. How better could you get? Okay. Also, the deadline for host is Monday. And then once that is closed, we will start the application process for the students. So just go to the species webpage and find out how this is done. Okay. Next. Well, this is the thing. You have to contact Christine, and the deadline is April 30th for the students. Okie doke. So, Aniko, do you want to talk about this? The Springer Nature Partnership? No? Okay. So basically, we have a partnership with this computer science journal, SNCS, and extended versions of the papers, selected papers in EvoStar, get published. We already published one issue in 2020, Evolution, the New Revolution, with an invited paper by Peter Angeli. And then there are 4 issues in the pipe for 2021, and more are going to come from the outcome of this conference. All right. So selected authors will be contacted by email in the next coming weeks. Okay. So this is for Joao. Joao is our media chair. There, I'm not pronouncing it correctly. I know that. Joan Correa. Joan. Okay. This is the impact we have in Twitter. How many users of the website, visits, Twitter impressions, and Facebook. It doesn't say that we have quite a few followers in the YouTube channel, because I'm the one who controls that, and I didn't get the figures, but. So we have quite a few followers. And one idea that we had was, if you want your presentation to appear in the YouTube channel, make a short version of it, and then we will make a call and you can submit it so that it will be published in our channel. And then you can have a bit more impact of your research. Okay, right. If you think this is over, it's not over. You will be still getting mails from us, and in one of those mails there is going to be the survey. So you will be asked for feedback, and it's quite easy to complete, and then we might take into account what you say. Then we might not, but this is important in particular for the hybrid formats. Also, we have an email for suggestions that we read very rarely, but you can send your suggestions there. Okay, we'll be very happy to have you sending suggestions. In particular, I would like to know if you would like a t-shirt for next year. How many of you want a t-shirt next year? Quite a few. Okay, fair enough. Right, okay, we can do something about it. Sorry?
Possibly this year too.
No, this year, no. Sorry. No. Well, there's a few left. Maybe we could have a contest like we had last night, a raffle. Would you like that, a raffle? Okay, docs. So, okay, so next year, we don't know where it's going to be next year, but we have 2 extremely good candidates. One is Brno, and I'm guessing I'm saying this right. In Czech, is that right? Okay, thank you. And the other one is Edinburgh. And this will be decided in the next few weeks or so. So you will if one doesn't make it this year, it will be there the next. So I think they're both. And Brno has the peculiarity that this guy in black, this is Mendel, and Mendel, I mean Mendel and Darwin are our 2 like godfathers, so to speak, right? Okie doke. So thanks. How am I doing for time? I'm still okay. Well, okay, though. We have many people to thank, and our invited speakers, Gabriela and Pedro Larrañaga. So thank you, big hand for them both. And then to all the conference and special session chairs, I'm not even going to start reading the list, but you're all great. We love you, and you did such a great work. May I say maybe that EvoApps will run a call for special sessions soon, so you will be asked to come up with ideas for new special sessions. And especially we want to thank these three people, Juan, Sergio, and Tiago, and these photographs are of ages ago. Come on, guys, I mean, no. And Joe is also the publicity chair. He's the one who sends all the emails. Yeah, you look great, but I don't believe, well, maybe Tiago. Tiago is okay, he's still the same. Okay. Sorry. All right, so thank you very much. Next, the EvoStar Task Force. We have Francis and Nuno, and we love you both because you have done such a great job. Where are you? Nuno, where's Francis? Oh, there. Thank you so much. Well, above all, we have Iñaki, who is a pain in the ass, but he's the best pain in the ass ever. Of course, to all the team. The team. Oh. Okay, so big picture. Say hello to online people. Hello. Yes, guys. If you had come, you would have seen them in person.
Hello.
Come on. Somebody take a picture of Laura. Yes. Can you take a picture of it? Yes. Show your pictures.
Yes. Okay.
Well, finally, thanks to you, because without you, we wouldn't have a conference and we couldn't have so much fun. So see you next year, wherever it is, but in person, please. And don't forget to submit a paper, our classic deadline, November 1st, and start planning. Tell everybody. So please tweet as well about how great conference you had, and we'll be getting back to you soon. Okay, thank you very much. Sorry, the species AGM is today at 2:30. Okay, so those of you, you know, EvoStar registration, if you tick the box, you were members of species. We need volunteers to help us do stuff like student mentorship, community building, and all sorts of things. So the AGM is today after lunch, okay? And we're waiting for you for lunch. Okay, so I think that's me. Yes. Yes, that's it. Okay. Bye-bye. ¿Cómo se para esto? Okay.